Hi, everyone. Welcome to the Open Source Developers at Google Speaker Series. My name's Kevin Barillion, and Bob Lee and I built this framework called Guice, by which I mean Bob did most of it, and I helped. And so it's my pleasure to introduce Bob to you, who's going to talk about the Guice Dependency Injection Framework. And that's about it.
Cool.
Bob Lee.
Is this thing on? Can everybody hear me okay? Okay. I started it, but Kevin made it what it is today. So today I'm going to tell you about Guice. I'm going to start off telling you about dependency injection in general, and then we're going to get into how you can use Guice to make dependency injection even easier. Why are we here? Why are we even interested in dependency injection and Guice specifically? The main reason is to make unit testing easier. So it makes unit tests easier to write, less friction. Kind of a secondary reason is you can use this to get some more decoupling in your code if you want to break down your code into compile time independent modules. Guice, not necessarily dependency injection in general, Guice can help you write less boilerplate code, which I personally love. I mean, a lot of times we write this same code over and over again. We re-implement these same design patterns without even realizing we're doing it. Our eyes just kind of glaze over and we don't see the code anymore. And then I guess kind of the overarching theme here is going to be getting better maintainability. So Guice was built for what I consider a huge project, millions of lines, 100 some odd developers, code going back as long as and longer than 5 years. So maintainability is of the utmost concern. I mean, you write the code once, people read it thousands of times. The way I like to explain dependency injection in pretty much any programming topic is through code examples. So I'm going to start off with a very simple example, unbelievably simple, but just enough to kind of illustrate the concepts. This is going to be the high-level design for our example. We're going to have, this is just kind of like a class diagram. We have the kind of central concept, the central thing we're going to be worrying about through this example is a class we'll call client, could be anything. And we're going to be testing client. As you can see, we have our client test over here. And client's going to have a dependency on an interface we'll call service. And we'll have one implementation of service, which we'll call service impl. Pretty simple. We don't really care what these things do. We just care about the fact that we have a dependency. I'm going to take three approaches three approaches to solving this problem. The first one I'm going to start off with is something where I'm sure everybody's familiar with, the factory pattern. The second one I'm going to show you is dependency injection by hand. Dependency injection is just kind of a variation of the factory pattern, the way I look at it. You don't necessarily need a framework. And the third example is going to be dependency injection with Guice. I'm going to show you how Guice benefits you over doing dependency injection by hand. And for those of you that don't know what dependency injection is, you're going to find out. And for those of you that do, I promise you won't be too bored because it's kind of fun to take a step back and examine what we know and identify exactly where and how much dependency injection helps your code. So throughout this example, as we go down these three paths, we're going to have one variable. And that's going to be one thing that's going to change. That's going to be how client gets access to an instance of service. And then a couple things are going to stay the same. We're going to have, like I said, we're going to have this service interface. We're going to have a single implementation of service. We don't really care what this interface looks like or what the implementation does for the purposes of this example, but let's just assume that it's something expensive or something we don't want to do during tests, right? Like it could be like charging a credit card. We don't want to charge a credit card or send off emails during our unit tests, right? So in that respect, we're going to have a mock implementation of service that we can swap in for unit tests. And that's pretty much what we're going to do. So the first approach we're going to take a look at is using the factory pattern. So here's our implementation of client. Like I said, this is stupid simple. And the way client gets access to a service using this approach is via a service factory. And in this case, we're just going to call out to a static method. And we'll call that our factory method. And then client does what it needs to with service. And to support this, we need to write this service factory. And this is kind of what I was talking about when I mentioned boilerplate code. We all write this same factory code over and over again. We have to make this upfront decision whether we just want to new up an instance of service and depend directly on the concrete class, or whether we want to go through the pain of decoupling client from service using factory. In this case, I just wrote the code to implement a singleton. I mean, I'm sure we follow this pattern hundreds of times. You might write some lazy loading code, or if this wasn't a singleton, this code might be a little more complex. And so, as you can see here, we have this is the method that the client used. We have this get instance method. This is what clients use to get access to our service. And I guess the main point of this is that client doesn't depend directly on the service implementation anymore. At least it doesn't seem to. So all client knows about is service. It doesn't know about the actual concrete implementation. And then if we want to be able to test this thing, or test things that run against this service factory, we need to be able to swap in an alternate implementation. So that's what this final method, this set instance method down here, allows us to do. So this is the thing we're going to be most interested in throughout these examples, and that's the unit test. So as you can see, in this unit test, so let's look at the middle part first. We're creating a mock instance of service, and we're passing that into the factory. And then we're running client, and then we're testing that client did what we expected it to do. And this kind of like outside stuff up here is us kind of saving off the previous state of the factory and then restoring it at the end. And does anybody know why we do that? Why we have to restore the factory to its previous state at the end of our test? There you go. So you don't break other tests. And by that we mean many of us have run into that situation where you run your tests in one order and they all pass, or you run your tests in a different order and they fail because maybe a test that ran after this picks up our mock implementation. Well, that's not the case since we're cleaning up in a finally block. I'm sorry? So you just made another great point. What if we have a test running concurrently on another thread? Yes, these two tests would step on each other. That's another reason the factory pattern sucks. So I already pointed out that, so what are the consequences or the observations that we can make about using the factory pattern here? I already pointed out that we have to kind of set up and make sure we clean up at the end. And if we forget to clean up once, then we can get mysterious test failures, and those are really hard to track down. One of the things that kind of strikes me is that when we're setting out to test client, well, in this case, it's simple. It's easy to know that we need to swap in an implementation of service because the client implementation is so simple. But it's not always that simple, right? It's our dependency on service might have been nested like 10 levels deep in our implementation, and we'd have no way of really knowing that we needed to swap that in. And I guess kind of the consequence of that is you end up having slow unit tests because you have random code out accessing remote servers and slowing things down, hitting databases and that sort of thing. And it's really hard to track those things down. And so I guess the crux of that is that the only way we can know from our test that client depends on service is by digging through the implementation. Reusing client in different contexts is difficult. So as someone pointed out, reusing it from different threads. We can't use different service implementations from two different threads. Or if we want to if we want to pass in a different service implementation to a client in one part of our application and a different one into the other one, it's really tricky. I already pointed out that we have to write that same factory code for every dependency, and that's a huge pain. It forces us to make this upfront decision whether we want to be tightly coupled or loosely coupled. And a lot of times, the thing I don't like about that is that we make the decision based on the wrong reasons. We make it based on effort when we should make it based on whether we want this to be tightly coupled or loosely coupled. And finally, we decoupled client from service impl directly, but the way this is set up is client still depends on service impl at compile time, because client depends on service factory and service factory depends on service impl. So we need to compile everything together. And we could kind of alleviate that using the service locator pattern or something like that. But the service locator pattern has its own problems. Like, for example, if we were specifying the implementation of service in a properties file or in an XML file. Well, with a lot of service locator implementations, we wouldn't know whether we configured that implementation properly until we went to actually use it. And that's too late for most times, considering you'd have to have like 100% test coverage. So now let's look at how things change when we follow dependency injection by hand. So if you remember in the last example, client just called out to service factory. Well, in this example, instead of calling out somewhere to get its dependency, client is going to have its dependency provided to it. And in this case, we're going to provide service to the client through its constructor. And then client just holds on to that dependency and uses it as needed. And this is what we call dependency injection. That's all. That's it. It's as simple as this. A lot of people refer to it as don't call me, I'll call you. So what does this do for us? Well, this is the same unit test we just looked at a couple minutes ago based on the factory design pattern. And as you can see, we have to set up, we have to save off the previous implementation and do all this setup and tear down, which really sucks. Well, if we have this implementation of client where we can just pass any service to the constructor, we can simplify our test considerably. Like we can get rid of all that code. We can get rid of this kind of dependency on a third party. Our test no longer worries about service factory. It doesn't have to. This makes the dependency explicit from our test too. You can't even create a client without providing a service, right? So we're not going to pass in a slow service in our unit test. We're going to pass in a mock version. So really, this cuts the test down to like the minimal amount possible, the minimal amount necessary, and this reduces the amount of friction to writing unit tests. So people are going to do it more often. People are going to have less problems. Tests are more readable. So now, in the production code, how does client get an instance of service? And the answer to that is, like I said in the beginning of the talk, I see the dependency injection pattern as just kind of a variation of the factory pattern. So as we'll see here, as we can see here, we just introduced this client factory. So now we already have the service factory, but now we have the client factory. And instead of creating client directly in our production code, we go through the client factory. And now just it's really simple. Instead of client depending directly on the factory, we just move the dependency on the factory up into our factory. Did I say factory enough times? So the idea here is that we can have all these nice dependency injected business objects that are easy to test. And then on a layer above that, we can have all these factories. And the factories depend on each other, and they depend on our nice business objects. But the important thing is our business objects are easy to test. And that's what dependency injection does for you. So compared to the factory pattern, the test is a lot simpler. We don't have to deal with middlemen, in this case, service factory anymore. It's painfully clear that client depends on service. It's kind of, we can tell that information directly from the API now. We don't have to crawl down into the implementation anymore. We can use client in multiple different contexts. Somebody mentioned using client with different service implementations and multiple threads. That's trivial to do now, right? I mean, we could just new up a client, pass it its own service instance or service implementation instance. This is a really big one, and this was one of the reasons I originally created Guice. Client no longer depends on service impl at compile time. So we can actually have client in a separate compile time unit from service impl. So if I wanted to just check out client and compile it and run some unit tests against it, I could do that, right? So I could take like a big monolithic multi-million line app and break it down into separate compile time units. And then just run these fast unit tests on those. And then when it comes time to, like later on in the development process, I can do those bigger, slower integration tests. But the important part is I get this quick development turnaround time up front. Kind of the downside to doing dependency injection by hand is we have to write even more factories. As you saw here, we had to even introduce a factory where we didn't need one before. And that means we have to write even more boilerplate code, even though it's not quite very much. So this final approach we're going to look at is how we can take this dependency injection example and implement it using Guice. So why would we want to do this? As I already said, writing factories is tedious. with these simple singletons that we've been writing, I mean, it doesn't seem so bad, but it's still pretty bad. You could generate that code, right? But as you get into dealing with scoping and that sort of thing, it's like, okay, I don't want this to be a singleton anymore. I want to return a new instance every time. Or I want to return the instance from the HTTP session. Or I want to return an instance from a thread local. It's like you got to write that same boilerplate code over and over again. We want more upfront type checking. So when our application boots up, if we forget to kind of configure a dependency, we want to know about that right away, as soon as possible, which you don't get if you're trying to use something like the service locator pattern. We want more flexibility. We want to be able to, I guess, how do I say, do more stuff kind of like analogous to being able to do reflection in Java. We want to be able to define dependencies automatically and that sort of thing, so we can cut down code and do some more dynamic things. And this last point is one of the biggest things for me, is we want to make it easy to do the right thing. I mean, we could see the benefits of doing dependency injection by hand, but the truth is, if your developers don't really kind of get or buy into dependency injection, I mean, it's kind of hard to stick with, The easier thing to do is just to kind of hard code the dependency in your code, right? It's not easy to remember to limit your dependencies to the factory level. It's hard to remember to abstract that stuff out. Well, with using a framework, one of the things you'll see is it's easiest to have things injected. It's almost just as easy to have things injected as it is to just new it up in your code. So instead of having these factory classes in Guice, service factory and client factory, all that boilerplate code, in Guice you configure things declaratively. So instead of having service factory in Guice, I just have this, I implement this interface called module, and this is how I configure Guice. And I can use this, what we call a domain-specific language to communicate with Guice. And all that basically means is that we have this kind of like nice little English spoken language sort of thing that's very readable. And so in this case, we want to tell Guice that whenever you see somebody that needs service, we want to give them a service impl, and we want it to be a singleton. So the way you do that is you say bind service to service impl in scopes.singleton. So we're saying bind the service interface to service impl and make it a singleton. And this replaces all the factory code we just had. So client changes just a little bit from our previous approach. We have to tell Guice where we want things to be injected. And when we were doing this stuff by hand, we knew, and we did the injection manually. But now we have to be able to tell Guice where to inject things. And the way you do that is you use an @inject annotation. And you can place that on constructors, methods, or fields. In this case, we're injecting a constructor. So this @inject annotation tells Guice, OK, when you new me up an instance of client, when you create an instance of client, pass me an implementation of service. And Guice looks at our module that we configured, and it says, oh, hey, client needs a service. Well, I'm going to go get him a service impl, and I'm going to reuse this same instance every time. Yes?
So is it going to inject for only the first argument or for all the arguments?
He asked if Guice only supports one argument or multiple arguments, and the answer is Guice supports multiple arguments. So, and the ordering doesn't matter because it matches things based on type. It looks at service. It doesn't care whether it's the first argument or the third argument. It's always going to bind to the same thing. So our test looks exactly the same as when we were doing dependency injection by hand, and this was kind of our end goal. We want to make unit testing easy. I guess kind of the one thing to notice here is that we don't use Guice in the unit test. We don't need to. We don't need that complexity. The simplest possible thing is just create our mock and pass it directly to client, right? So conclusions based on this simple, unrealistic example. Even in this little example, Guice melted away like 20% of the boilerplate code. And that's over the initial example, with a more concise example, because we didn't have to write all that factory code. And one of the really nice things about Guice, especially compared to other frameworks, and this approach to using annotations for dependency injection, is that we already saved that 20% in this little example, but where Guice really shines is the more you use your dependencies. So you're not going to go to all this effort just to use a dependency once, right? I mean, some dependencies we use hundreds and hundreds of times. So, but each of those times, now the only thing you have to do is put @inject on your code and take service. So you don't have to go and set up the module anymore or anything like that. So a lot of times, if in an application, your dependencies are already set up, so you don't have to worry about it so much. We get more startup checks over using a service locator. So one of the things that's really nice about Guice in particular is kind of the quality of its error messages. So if you're missing a dependency, like for example, if we didn't bind something to service, Guice would fail right away at startup before running any of your code. And it would tell you that client depends on service, and it would even give you the line number so that your IDE can link it in your log, and you can click and jump right to it. Guice supports this notion of declarative scopes, and what I mean by that is, remember in our binding we said, okay, this is in singleton scope. We only want one instance of this for our application. And you can implement your own scopes using Guice. It already comes with scopes for handling servlet code, which we'll get into that a little more. We have a lot of flexibility here. So you could imagine that, I mean, this is just a Java API. So you can write special code to create your bindings however you want, right? You could loop through a list of interfaces and automatically create bindings for all those, right? Imagine like your data access objects. If you're able to, if you just had data access object interfaces and you were able to generate Hibernate implementations for those. Some people do this sort of thing. And I guess like my favorite part is just this makes for easier upfront design decisions. Whereas before we had to decide whether we wanted to new up the class directly and have this concrete dependency, or if we wanted to write all this factory code. Well, now it's just as easy to just have the concrete class injected to begin with. So it's like so client depends on service. We could start off with service just being a concrete class to begin with. And client doesn't care, right? It doesn't care if it's an interface or concrete class. And then when we come by later and decide to abstract out an interface from service, well, we just do that, and client doesn't have to change. So we make our change in one place, and none of the clients have to change. So it makes it easy to do the right thing. So now that we're all, oh, we have another question. Feel free to interrupt me at any time, please.
I didn't understand the added inject, the line add.
So we'll get into that right now. He asked a question about @inject. So you're wondering how Guice knows to inject that, or?
Is that Travis?
Oh, okay. So this is, I'm sorry about that. I kind of jumped ahead a little too much. So he's asking about this @inject here. So one of the main reasons I created Guice when I did, I started a little over a year ago, was because Java 5 had been around, and none of the other frameworks really took advantage of that. One of the things that were introduced in Java 5 were annotations, and that's what this is. This is basically just kind of type-safe metadata that you can attach to methods, fields, classes, whatever you want. And so at runtime, Guice can look at this client class and see that there's an inject annotation on here and know to inject that. Yes?
How does this differ from Seam that uses annotations as well?
It's actually, so he asked how this compares to Seam. Guice is actually similar in a lot of ways to Seam. We're going to see some ways where it's really different. Seam is a great framework too. And I'm actually on a JSR called WebBeans with Gavin King, who created the Seam project. And we're combining Guice and Seam for WebBeans. So we're going to, it's actually, it happens to be very little overlap between the two, but you need both, the way we look at it. So if you're interested in this stuff and you're interested in the future and you don't want to depend on a proprietary framework right now, then I encourage you to keep an eye on the WebBeans API. But there's definitely a lot of synergy between Seam and Guice right now. I'm sorry about that. I jumped ahead too far. So now that we're sold on the virtues of dependency injection, I'm going to show you how to get started with Guice and sold on Guice. So what does a basic Guice application look like? We looked at that simple example, but we left a little bit out. It's like, how does Guice create an instance of client for us, right? Well, so that's what we're going to look at right here. I guess kind of the central object in Guice is called the injector. This other frameworks might call this like a container or something like that, but the injector is what creates our objects. And so if we wanted to use Guice to create an instance of client, we just ask Guice to create the injector. We pass it our module. This is the same module from our example. You know, the module that says bind service to service simple. So we pass Guice the module, and then it gives us back an injector. And you can pass it any number of modules you want, and the modules can all be independent. Then we take that injector, and we ask Guice, we say get instance of client.class, and Guice will give us an instance of client. It'll call that constructor, inject whatever client needs, and give it back to us. In this case, we didn't need an explicit binding for client because client's a concrete class, and Guice knows how to create it. If client was we could also pass Guice an interface here, but we need to tell it what's bound to that interface somewhere. And then we can just call, in this case, we just call client.go. In a real world application, say this was like a command line application, this would be kind of like our main method would look very much like this. If this was a web application and you liked to have direct control of your servlet container, you might have Guice create your servlet container and then call start on your servlet container here. There's also ways to wire up web applications that are a little more, you can just kind of drop them in and use them. One thing I want to kind of point out here is that what kind of situation would we have if we always asked the injector for our objects? We wouldn't have dependency injection. We'd have a service locator, right? Which is what we're trying to avoid. So that's where this idea of, I like to call this bootstrapping. So this is really the only time that we're going to, ideally, this is the only time that we're going to deal directly with injector, is in this kind of bootstrapping code right here. And this is kind of one of the things that is really cool about dependency injection, and this was kind of like an aha moment for me whenever I started using it, was so we use Guice to create an instance of client, and then Guice creates objects to inject into client, and then Guice has to create those objects too. And then so Guice creates objects to inject into those. And you kind of have this recursive object graph that Guice can create. Well, we only depend on injector here, and we only ask it to create client. But from that root object, Guice can construct our entire object graph. And then from our perspective, all of our code is nice, clean, and unit testable, right? We have these nice unit testable business objects that just depend on interfaces and whatnot. And then we have these really simple modules where we just kind of describe the dependencies. So Guice gets rid of all that boilerplate code, makes things easier to test. And that's how it does it.
Does it mean that the entire object tree is created at startup, no matter what?
So he asked if this means that our entire object graph is created at startup. And the answer to that is no. Guice does provide ways to delay object creation. And I'll definitely get into that. So you can kind of lazily create objects as you want to. So Kevin B. so the idea here is one thing I kind of want you to note is that for an object to be injected, Guice has to create it, right? Kevin B. calls this into club. The objects have to be into club. And so if you see new in your code, that's kind of bad. So let's say we want to introduce a new dependency based on kind of like this idea I was talking about, bootstrapping. Well, let's say service, we want to add some emailing capabilities to our service simple. All we have to do there is first we have to create our emailer. And this could be, in this case, we're just going to make emailer a concrete class. And in service simple, we can create a field for emailer. In this case, we're going to use field. We can also use method or constructor injection. And then we put @inject on that field. So now whenever Guice goes to create an instance of service simple so that it can inject it into client, it's going to create an instance of emailer and then inject it into service simple. So notice we didn't have to deal with the injector at all directly here. So then service simple, at the end, it's going to do whatever it was doing before, and then it's going to send a confirmation at the end using the emailer that we injected. So there's some situations where, so far what we've seen, we've had one implementation per type. There's going to be other situations where our application is a little more complex. We're going to have multiple implementations of the same type. So hypothetically, we might have our regular emailer, and then we might have a transactional emailer. And why the heck would we want a transactional emailer? Well, let's say we're processing orders. You don't want your order to go through if you didn't send the client a receipt, right? If you didn't validate the email address and that sort of thing. And you don't want the receipt to go out if you didn't actually process the order. So we're going to need a transactional emailer in this case. This is kind of one of the big innovations Guice does compared to Seam and some other frameworks. A lot of frameworks you might have seen rely on string tokens to identify dependencies. Guice uses this idea of binding annotations. And so in addition to saying @inject emailer, well, now we're going to say @inject @transactional emailer. And Guice is going to look at this and say, oh, you need a transactional emailer. And the idea here is that the thing that's going to identify this dependency is it's an emailer, and it's transactional. So the way we configure this in our module is we say bind emailer annotated with transactional to transactional emailer. Transactional emailer is our implementation. Everybody follow that?
So the transactional annotation, is that part of the Guice framework?
So he asked if transactional comes with Guice, and the answer is no. Guice does come with some binding annotations, but you can just define these things on your own. You don't have to create one every time you have two implementations of something. Your binding annotations can be kind of general and reusable. Like this is transactional. We can use transactional with an emailer. We can use it with a service. We can use it with a database connection, whatever, right? And that's, from our experience, we find that that's often the case.
The annotation, basically.
Yep, this is a, yeah, yes, if this is an empty annotation, and yes, this is like a marker annotation. It doesn't really, in this case, it's a marker annotation. But in reality, Guice also supports, you can have attribute values on these annotations too. So that saves you from having to create new annotations all the time also. Like you can have one annotation and you can have like a string value and pass it to it or that sort of thing, so you can reuse it that way. So, and this is actually an example of that. So in addition to having multiple implementations of things, sometimes we need to, oh, got another question.
I was going to ask, is the name of the annotation, does it match with the class name?
Does the name of the annotation,
The marker annotation, transaction,
does it match the annotation class name?
same as the class name?
No. So he asked if the annotation class name has to be the same as the implementation class name?
No,
Is-
but the name of the annotation.
This is a type of the one I follow.
Oh, pointed out that I forgot a C right here. Sorry about that. So yes, this would have to be the same as that. And you'll get, that's one of the nice things about Guice, you'll get a compile time error. Actually, you wouldn't make that mistake because your IDE would autocomplete. Keynote doesn't autocomplete. So sometimes, so we just looked at the example where you have multiple concrete implementations of a single interface. Well, sometimes you're dealing with third-party code where you can't apply @inject, or you just have some code where it wouldn't make sense. And you need to create these, or maybe you can't let Guice create the objects. Maybe they're already created and you don't have control of that. So you need to have some way of, you still want to be able to inject these things into other classes, right? So here's an example of that. Let's say we couldn't let Guice create an instance of emailer and we wanted to create it ourselves. So that's where Guice provides this interface called provider. And all provider is a simple interface with a get method that returns an object. It's as simple as that. And to tell Guice that you want to write a custom provider, in this case we're going to provide an instance of emailer, you just say bind emailer to provider, and you give it a provider of emailer. And kind of the nice thing about this is that even though we can't inject emailer directly, we can inject our provider. So we can inject our provider, and in this case, we're going to inject the name of the email host, like the email server name, and then we can take those values and pass them on to the class. So the interesting thing here is that service info wouldn't have to change. It doesn't care whether Guice is creating emailer or whether we're creating it manually in our custom provider. It doesn't matter. It's completely decoupled. Couple things to note here. Here's one thing, that scopes can still apply to your custom providers. So even though I want emailer to be a singleton, I still don't have to write that boilerplate code in my custom factory, right? I can still apply this same scope to my custom provider. And then this gentleman here asked about whether binding annotations always had to be marker annotations, and this is an example of when it doesn't have to be. Juice comes with this annotation called @named, and this is an annotation you can use if you don't want to create a custom annotation all the time, if you just want to kind of revert back and use string names to identify your things. And so you can kind of see here, we do @named, and then we just have email.host. So I touched on scopes. Let me just kind of go into a little more detail on that. The definition of a scope is it's a policy for reusing objects. By default, Juice uses no scope for your objects, and that basically means that it creates a new instance every time, passes in a new instance every time, which makes things very keeps your objects separate and makes it nice and object-oriented. There's two ways to specify a scope for a given binding. My preferred way is to use an annotation. That's this example down here. So if we wanted to tell Juice that emailer is always a singleton, you can just put @singleton on emailer. And you can define your own annotations like this for your custom scopes. So if you were using Juice's servlet module, you could say @request scoped. And that would tell Juice that you want it to be stored on the request. And Juice would just automatically do that for you. Sometimes that doesn't work, like I said, in cases where you have like a custom provider and Juice doesn't create your classes, or if in those cases you can specify the scope in the module. So even if email is a concrete class like it is here, you can just say bind emailer in session scope, and Juice will do that for you. All right, so somebody asked a little earlier in the talk whether whenever we do that initial bootstrapping, is Juice going to create all my objects and construct my entire object graph? And the answer to that is no, and it's for this reason right here. You can, for any type foo, you can also inject a provider of foo. And this is just the same interface, just reused here. The same interface we used to provide objects to Juice, Juice is going to use to provide objects to us. So in this example, instead of injecting money directly, I'm injecting a provider of money. And as you can see here, we can call get and get 2 instances from that provider. Instead of just having, normally Juice would only inject 1 instance. Well, in this case, we can get 2 instances out. So there's a few cases for injecting a provider instead of the object directly. And those cases are, one, if you want to get multiple instances, like this. Normally Juice only would inject 1 instance directly. A second one is if you don't necessarily want to create an object. Maybe you have multiple dependencies that you may or may not need, and you don't want Juice to be creating all these objects that you're not going to use. So you can inject a provider and then kind of like lazily ask Juice for that object, only if you need it. And then the third reason is what I kind of call transcending scopes. So sometimes you might want to be able to access a request scoped object from a session scoped object, right? But session scoped is bigger. So if you just injected a request scoped object into a session scoped object, well, you would hold on to that object from the first request the entire time, right? And you'd be out of scope of the original request. Well, so instead of doing that, you can inject a provider of that object, and then the session scoped object can just ask it when it needs it. So, and then Juice will behind the scenes. So it can just ask for, it can say provider.get me this request scoped object, and Juice will just dynamically in the background look up the object from the current request. I mentioned that Juice supports constructor method and field injection. Let's kind of talk about the pros and cons of these. My personal favorite is constructor injection, and it's because I like to make everything immutable. It makes thread safety easy, makes your code nice and maintainable, because you can see right away that this field can't change, so you don't have to worry about it anymore. You know exactly what its value is going to be. But there's sometimes when constructor injection won't work, and that's when method injection is a good option. Sometimes I've run into cases where I don't want, where somebody maybe extends my class, and I don't want them to know about have to worry about my dependencies. And the reason for that is, as you know, if you extend somebody's class, you have to call their constructor, right? Well, if they have to call my constructor and I take my dependencies in the constructor, well, that means my subclass has to be responsible for passing me all those dependencies, right? And if I add a new dependency, I'm going to have to go through and change all my subclasses, which is kind of contrary to what we're trying to accomplish here. We want to kind of isolate changes. So that's where method injection is a good option. Juice will just call like your setter method or whatever you want. Your method can be named whatever you want, without the subclass having to be the wiser. Another case where method injection is good are these cases where Juice can't create your objects. So maybe the object already exists, or it's a third-party object, something like that. Or, well, I guess this wouldn't work in the third-party situation. But if your object already exists and you don't want Juice to call your constructor, you can still ask Juice to inject your methods and fields. Obviously, you can't inject the constructor after the fact because it's already run. And then the final case we have is field injection. And I find that that's good for custom providers. We saw that back here. I used field injection right here. I mean, we're not really going to unit test this code. This code will get covered in our integration test, but we're not going to bother unit testing it. So it's OK to use field injection here. And then the other case is slides for your talk, because it's the most concise and takes up least space. All right, so I'm just going to talk about some more features that we didn't get too deeply into that you might want to check out after the talk. The first one is type conversion for constants. And so this is where you might ask, OK, I'm hard coding all of this in Java. I want some of the configuration information to be externalized. And like something like Spring or something like that, it would be like an XML file, right? And you'd be able to change it without recompiling. Well, Juice supports that too, in a slightly different way. We think you should only externalize what should be externalized. You should only externalize the stuff that can actually change, right? It makes things a little more readable and keeps people from breaking your application, and makes it more usable. So Juice has some support for doing things like you can slurp in an entire properties file, and Juice will create bindings for every property. And the way it does it is it creates bindings to type string, and it uses that at named annotation that we saw already. And it uses the property name with that named annotation. And so this is then, this is where the type conversion comes in for these types of values. You don't necessarily just have to inject string into your classes. Juice can take that string from your properties file and convert it to an int, convert it to a class, convert it to an enum. Enum's kind of an interesting one. And what's really interesting about this is that Juice does this all at startup. Because Juice can look at all your classes and know that it depends on these constants, right? And it converts that value once at startup. And if that conversion fails, Juice blows up, and it says, hey, this value forgot to fail, or failed to convert. Another feature that Juice has is I've been a big fan of AOP in the past. But the truth is, I even wrote an AOP framework, which was even one of the simpler ones at the time. The truth is, what do most people use AOP for? Applying transactions, right? It's you just put @transactional on your method, and it tells the framework that you want that method to be run in a transaction. Well, Juice has support for this sort of thing, and it uses the AOP Alliance API, which means you can take like Spring's transaction interceptor and use it directly with Juice. So, and then you can just apply @transactional to your methods, and just like Spring, just like EJB, that method will be run in a transaction. Juice introduces a new concept for, I guess, kind of this class of framework. It's what we call development stages. And so one of the things I noticed about other frameworks were they made you specify hard code in the configuration file whether you wanted your objects to be, your singletons to be lazy loaded or not, right? Well, to me, it depends. It's during development, I want all my singletons to be lazy, or as many of my singletons as possible to be lazy loaded, so that I'm only initializing parts of the application that I care about, the parts that I'm working on, the parts that I want to test. So my server starts up as fast as possible, and I can do my testing, make some changes, start it again, make some changes, start it again. Whereas in production, I want the exact opposite. I want all my singletons to be eagerly initialized at startup, so that I know that whether there's any errors, whether I'm missing anything, or whether a singleton's going to fail to instantiate, and so that my first clients that hit my server don't pay the performance penalty, right? So you get consistent performance. So Juice lets you specify, right now it lets you specify development and production stages. And it does It has that behavior for singletons like I just explained. But it also makes this information available to your modules, so you can write custom code based on whether you're running in development or production. So I'm going to kind of glaze over optional injection. We're not really that worried about it. It's not something you use that often. But let's just say that Guice will fail fast if you're missing a dependency. So that's one of the things I kind of really like, and that makes it really maintainable. If you forget to define a dependency, Guice is going to tell you, and it's going to make it very clear. Guice also comes with integration. Out of the box, it comes with integration with JNDI, pretty good integration with Spring, the Java management extensions, JMX, and Struts 2. Struts 2 is kind of one of the main reasons that I created Guice. I was working on Struts 2 whenever I kind of came up with a lot of these ideas and decided on what I want. So Guice comes with a great Struts 2 plugin. You just drop it in your class path. And everybody remembers, or you might remember when I was talking about bootstrapping before. Well, the Struts 2 equivalent of bootstrapping is that Guice injects all your actions. So instead of, whereas with Struts or WebWork or Struts 2, instead of your actions just having these no argument constructors, well, now you can take all your dependencies in your constructors and actually make use of your actions. It makes your Struts 2 applications a lot nicer.
So does it depend on all of those?
Someone asked if Guice depends on all these things, and the answer is no. So Guice is broken down into separate modules, so you can kind of take what you need. The JNDI one is in the core Guice because JNDI is in the core JDK already. But the Spring one is just a separate jar that you can include if you want to use that. Same with Struts 2. JMX is in the core jar also. That's one of the kind of philosophies and one of the things I'm trying to do with Guice. I want to keep it really simple and stick to, for the most part, stick to pure dependency injection. And I want to provide the hooks and the capability so that other people can build third-party frameworks on top of Guice, which people are already doing a lot. I mean, there's already people working on Hibernate integration, dynamic web remoting integration. You can, if you join the mailing list, you'll see that there's a lot of traffic, a lot of people working on different things. Give you a little taste of some upcoming features. Kevin and I should be pushing another release probably in the next couple months. One of the things that's kind of annoyed me is we looked at that custom provider. Even using an anonymous in our class, it's kind of a pain, right? It's more code than we want to write. You don't really have to write that code all the time. That's probably like the maybe less than 5% case where you have to manually configure your objects. But in the next release, we're going to make that even easier. You're going to be able to have one class with multiple, where you can just have a bunch of factory methods. We call those provider methods. And those methods will take in their dependencies as parameters, and then they'll return the thing to be injected as a result. So that'll cut down on a lot of boilerplate there and give you a really nice, kind of a nice way to configure your objects and that sort of thing. The next one is mixed automatic and custom injection. So right now in Guice, you have to make this decision. You either have to let Guice create your object and inject it, or you have to configure it 100% manually. Well, in the next version of Guice, you're going to be able to kind of do a little bit of both. You're going to be able to say, hey, Guice, inject service impl for me, and then let me do some kind of like post-injection initialization on it. We're going to make that really easy. And then the third thing that's going to be really important is this idea of construction listeners. So Guice is going to provide a hook for you, and you can also do your own checking at startup with this, where you can listen to the creation of any objects you want. And what that means is that if anybody's familiar with like EJB3, well, you'll be able to implement EJB3 on top of Guice now, because you'll be able to write a custom construction listener that looks at the objects and says, oh, hey, I see an @resource annotation here. Well, I can get my dependency out of Guice and then pass that in to that method with the @resource annotation. And you'll be able to write like custom code for like registering your objects with listeners and doing pretty much whatever you want. I mean, you have your own hook into construction. And it's going to be a general thing, too, so you don't have to repeat that code over and over again. Does anybody have any questions? Or actually, I think Michael had an announcement, right?
I do. Grab this. So I run one of the Java user groups that meets here on the third Tuesday every month. How many of you have been here for one of the Java user group meetings? Okay, well, the rest of you, if you want to find out about them, there's one real easy way. We have a Java.NET project, and you can either join our mailing list subscribe to the OSS feed of any announcements. So I'm just going to leave these up here, and hopefully we'll see you in 2 weeks. We actually don't have an announcement up yet for this week, this month, but we are going to have a presentation, and the announcement should be up soon.
Cool.
Great, thank you.
Thank you very much. 2 weeks?
In 2 weeks, same time, same place, 2 weeks.
Same time, same place, 2 weeks. Java Users Group meeting.
I just had a quick question. You have your core set of integration technologies with Guice. Do you have anything upcoming as well, or is that pretty much what you're saying?
So he asked if we have any more integration efforts upcoming. Like I said, there's some people working on the mailing list on various things, like specifically JPA Hibernate integration was one of them that I noticed. I'm not personally working on any integration things. My goal right now is to implement like construction listeners, because that's going to open the door to a lot more integration things. Like I said, you're going to be able to implement EJB3 on top of Guice and pretty much anything anybody else wants. So, yes?
How many people are using this framework right now?
He asked how many people are using Guice. Our downloads are, we released it, I guess like 2 months ago now, something like that. Our downloads are well over like 30,000 downloads already, so we're really excited. There's a lot of interest. The mailing list gets regular traffic every day. So I think it's just going to get better, like when we release the next version.
Does our Google developer use this one for testing as well?
I'm sorry?
Does Google developer use this one for testing as well?
Oh yeah, yeah. That's the primary reason that we developed Guice, was for unit testing, and that's kind of like the main driver behind it, is it makes your code easy to unit test. If there's any reason to use it, that's the reason. Yes.
Oh, EJB3 has dependency injection. Why would I want to use EJB3 over Guice?
So he said that EJB3 has dependency injection, and why would you want to use Guice? Well, EJB3 has kind of a domain-specific version of dependency injection with the at-resource annotation, and Guice implements a more general and typesafe approach to dependency injection. And you can actually build EJB3 and support its domain-specific version on top of Guice. So, and actually, I mentioned WebBeans earlier on, and that's an effort where we're kind of standardizing on this stuff. We're pulling in like the best of Guice and the best of Seam, and so like from the Guice world, you're going to get like these binding annotations and stuff, which EJB3 doesn't have an equivalent to. With EJB3, you still use like string identifiers and that sort of thing. And you're going to have the string identifier approach like Seam and EJB3 and that sort of thing. And then the idea is, hopefully, with WebBeans, that WebBeans is going to be kind of a generic component model. It's called WebBeans, but it's kind of a misnomer. It's going to be more general. EJB3 will be able to use WebBeans as its component model, and JSF will be able to use WebBeans as its component model. So you're not going to have like these two disparate ways of configuring objects and creating objects between two different specs anymore. You're going to have some more. It's going to be a little more cohesive. Yes.
Hey Bob, is it true that it is true? EJB3 doesn't support constructor dependency injection, does it?
I don't know that much about EJB3, but Paul pointed out that EJB3 doesn't support constructor dependency injection.
Nor will EJB 3.1.
Nor will EJB 3.1. And like I said, so that's a great point right there. I'm a huge fan of constructor injection. It's the one that I use probably 90% of the time, just because I'm such a big fan of immutability. It's a great way to. Yes.
So is Guice part of Google's code base, or is it?
So yes, if Guice is part of Google's code base, it was born in Google's code base, but then I open sourced it, and now I host it on Google Code, which anybody can use. It's kind of you can host your own source on there. Just go on and create your project.
So where do you draw the line between knowing every single object and injecting every single object?
So he asked where I draw the line between calling new, constructing objects manually, and between injecting. The answer was, my answer used to be that I would use dependency injection with Guice a little more often than I would have used factories before, because there's less friction and it's easier to use. But now I would almost always have everything injected, because it's not just the fact that I want to decouple myself. Like, maybe I don't necessarily want to decouple client from service, but maybe I want service to still be injected. And by having service injected, Guice has the opportunity to inject it and inject dependencies into service. And client doesn't have to know about those. So a lot. It makes sense to use this stuff a lot. I mean, even now, somebody released an IntelliJ plugin. I haven't had that much time to check it out. But even now, even though the tools for Guice are immature, it's still, it's very maintainable still, right? Because like in your IDE, when you depend on an interface or class, you can just jump right to it. Well, with Juice, you can still do that. So
is the decision as to which version of the service is going to be injected, is that decision made at compile time or runtime?
So he asked if when the decision for which service to inject is made, whether it's made at compile time or runtime. It's made at early runtime. So we kind of still wanted to do this stuff at runtime, but we wanted to know right away, right? You could theoretically do this stuff at compile time once we get like Java 6 and the annotation processing API and stuff, but I still think you kind of want some more dynamicity. And so the idea is that we saw these module classes, and you pass those to the injector, or you pass those to Juice to create the injector. Well, you can include different sets of modules whenever in your main method, whenever you start up your application. That's how you make the decision. So as soon as that starts, it's very fast. Juice is very fast about validating everything and running through your modules. You'll find out right away if you're missing any dependencies or whatnot. And one of the interesting things that Juice does is kind of blurs the line between compile time and runtime a little bit in respect that normally at runtime, if you run into a problem, you just blow up and you have an exception. Well, Juice doesn't blow up at the first thing. It fails early, but not too early, right? So what it does is it goes through your entire configuration, and it doesn't just stop at the first error. It goes through and collects all the errors and keeps track of all the line numbers for these errors. It gives you line numbers into your module. It gives you line numbers into your classes where you're missing dependencies and that sort of thing. And it presents them very nicely, the same way a compiler would. So you don't have to keep restarting your application and fixing every little error. You can get the whole list of them, fix them all, and your application will hopefully run.
Yeah, is Juice mature enough to start using now, or is the next release going to, you talked about a lot of enhancements and new features and things like that. Should we wait a little bit, or?
So he asked how mature Juice is, whether it's safe to use right now, and the answer is emphatically yes.
Yeah,
no, yeah.
Up or something like that.
No.
How much of a change is it?
So now is actually, it's a great time. 1.0 is very stable. We had a lot of experience with it. I mean, we were using this stuff in production for months before we even released it. We've been using it since I started developing it, well over a year ago. And 1.0 pretty much has everything that you're going to need. And there's little workarounds for the couple edge cases that you might run into. The next version is really just kind of nice to have and enhancements, maybe making the code a little more concise. Like I said, we're making the custom providers a little more concise, but even those, you write those maybe less than 5% of the time. So it's like, it's nice savings, but it's not the end of the world. Yes. So yes, if it's going to be compatible with WebBeans. It's still too early to tell, but WebBeans is going to look very much like Juice, and like I said, it's going to look like Juice and Seam combined. And it's really interesting because Juice and Seam have two very different injection approaches, so it'll be interesting to see how those fit together. But Juice will implement WebBeans, and it'll continue to implement its current API. We care a whole lot about backward compatibility.
Two questions. First question is you mentioned that Juice produces an error report saying the line number and the modules where it has an error. Would it also give me a report when everything is fine? Basically, I want to see what got injected in production.
Yes. So he asked.
The second question is, do you have any integration with any of the popular IDs, or I can just right-click and say inject, or do I have to keep going and say add inject and add inject?
So he asked, one, what kind of reporting Juice gives you when everything's fine, not just when there's errors, and two, how the IDE integration is. So to answer your first question, that's kind of where the JMX integration comes in right now. Juice has an API where you can kind of introspect on your bindings. And one example of using that API is a JMX integration. For those of you that don't know, JMX is a standard management interface where you can have multiple clients that all kind of speak that know about the same API. You can have like a little, and Java even comes with a little JMX client. So you can connect to your application. If you're using the JMX integration, you can connect to your application that's using Juice. And in your console, your JMX console, you can kind of see like a nice little GUI that shows you all your different bindings, and you can drill down based on type or based on binding annotation and find everything that way. Then he asked about IDE integration. Like I said, about a week after Juice came out, somebody came out with an IntelliJ plugin for Juice. I haven't tried it myself very much. I love IDEs, don't get me wrong. I use the heck out of them. I use every feature of IntelliJ. But the way Guice is set up is it's set up to be maintainable even without an IDE. A lot of cases, the harder case is whenever you depend on an interface, right? And that's already hard with or without Guice, right? It's like, how do I know what implementation of that interface am I getting? Well, most of the time in your IDEs, I just use the feature where you can kind of you can go to the implementation and you can, or the interface, and then it can show you all the implementations of that interface. Usually, it's pretty clear which one you get. But I also think it would be nice if we had an IDE plugin where you could say, okay, I'm going to use this set of modules to configure my application, and then based on that, tell me what implementation of service I'm going to get. And that's totally plausible. And that's one of the things we're working on to make even easier in the next version.
The constructors and methods have to be public.
He asked if the constructors and methods have to be public, and the answer is no. And the reason I made that design decision, they could even be private. The reason I made that design decision is, so you still want to control access. You can tell by looking at the Guice API that I only expose what needs to be exposed to clients. And the reasons for that are, one, to make your API simpler, and two, so that you can feasibly maintain backward compatibility. And then, so based on that, and the fact that you have to have that @inject annotation. So even though it's private, you still see the @inject annotation and know that it's going to be injected.
Would there be situations where two services are dependent on each other, and how do you resolve it?
So he asked if there's ever a situation where you have like two services that are codependent. And yes, that's another great reason that I didn't mention to use a framework like Guice, is that it automatically handles circular dependencies. So this is the idea when you have two implementations that depend on each other. And with Guice, it actually even does some fancy stuff. I don't like to encourage it necessarily, but even if you have two constructors that depend on each other, Guice can handle that case. And the way it does that is it'll inject a proxy into one for you automatically, and swap in an implementation of that proxy after it constructs the other object. So you can make everything final. Yes?
So if you're using a multi-language service-oriented architecture, presentation here, implementing Java, making service calls, SOAP service calls. Most of the services like they're more like service testers. Most of the services have like XML API.
Yep.
So in this setting, like most of the services are implemented in a non-Java.
So he asked how you can handle remote services that aren't implemented in Java with Guice. Can I assume that, well, I would assume that you're using a Java API to communicate with those services and not the XML directly. So the idea is that, so that's one of the things that I really like about the way you configure modules in Guice 2, is you can easily make these little utility methods and stuff in your modules, so that I could say, I could create a method called bind web service, and I would give it the interface that I wanted to use, like the Java interface, and then I would give it maybe kind of like the URL to the WSDL or something like that, or to the URL to the remote service. And then it would just automatically, just with that one method call, it would create a binding for that service for me.
Another question is, so Guice framework, like, it's basically like intended for unit testing. So these problems, you do a few services.
Oh, can you repeat the question again? I'm sorry.
This is like trying to manage how like a large application, client, so would it use a Guice framework?
So he asked about testing of a larger application. So in the
When I develop like a client code, making all these like service calls,
right,
it's like a series of large client application.
that's a great question.
It's composed of like multiple service calls.
Right.
More service calls.
Right.
So when I'm developing this like client side application, is it one like a client code base that I would use for testing as well as like deploying into production?
So he's asking.
Trying to, like,
So I think you're asking about how you implement kind of like medium-sized tests, maybe. So on the one end of the spectrum, you have these unit tests where you don't use Guice at all. We showed that and you can just pass in mock implementation. On the other end of the spectrum, you have full-blown integration tests where you're testing against your production configuration, which you definitely still need to do. But then in the middle, there's kind of this middle ground where it's still hard to construct your objects, and then Guice is great for that. I mean, you saw kind of the bootstrapping code in Guice, how simple it was, right? It's just a couple lines of code to kind of bootstrap a Guice configuration right there in your test. And in a medium-sized test, like say I wanted to swap in a fake billing service or something like that. So I'm not actually charging credit cards, but I still want to test like a bunch of objects together, like 4 or 5 objects that all interact. Well, Guice is great for that. So, and the idea is, whereas in my production configuration, I use one set of modules. Well, in this test configuration, I can use kind of some of the same modules, but I can also swap in like a fake billing module, which will install all the fake billing services and that sort of thing. So yeah, Guice is very good at that.
Does all of your configuration have to be built into the WAR file, or can you externalize parts of it so that as you move, for example, from development to test to production, you can keep that basically the same binary across the configuration outside?
By configuration, do you mean like the properties file, if you wanted to use that? Or? So he asked if Guice kind of mandates where your properties file has to be, and the answer is no. It's the utility method that lets you kind of generate the bindings off your properties file. I think it just takes like a reader or something like that. So you can get the URL using like a file reader if you wanted to get it off the file system, or a URL reader if you wanted to get it out of the jar, whatever. Or if you wanted to get it off remote servers, you could do that, right? So, and you could even kind of switch it based on whether you're in development or production mode too.
So when you give the Guice patterns talk?
Yes, when I'm going to give the Guice patterns talk. I think I'm going to leave that one to Kevin, because he's a better speaker than I am. Yep.
In the example which you showed, you had the bindings were like in the code, right? So you said bind service.class to service impl.
Yep.
How would I handle cases where my impl would not be known?
Oh, okay, that's a great question. So he's asking, what if he doesn't know at coding time that he wants to use service impl? Maybe he wants the client to be able to specify that class in a properties file or something like that. Well, that's why I specifically mentioned that Guice could configure. Well, no, I mean, I didn't mention it enough that you might be able to figure it out, but I mentioned that with the constant type conversion, Guice can also convert to classes. So you could specify a class name in your properties file, and then have that injected as a class somewhere, like in a custom provider or something like that, and then ask Guice for an instance of that class. And then Guice will blow up at startup if it can't inject that class instance. So you can specify, and let your clients specify an implementation dynamically.
I have a second question.
Uh-huh.
Many of the frameworks I look at, like even struts, for example, they have like one struts.jar, commons line jar, this jar, that jar, and there's like 10, 20 jars. By the time in the way development environment we work in right now, these things have to be checked in, CVS.
Right.
I don't know, I cannot control that. So how many dependencies do you get into?
Yeah, so he's asking how we deal with kind of like this dependency explosion, whereas all these frameworks depend on 15 jars. Guice doesn't help you there. It's if you depend on a lot of things, you're going to have a lot of jar dependencies.
How many does Guice create for me?
None. Well, you have the AOP Alliance API. Guice is very self-contained. It's very small. And it has no external dependencies that you need to worry about besides the AOP Alliance API. So it has 2 jars. It has the Guice jar and the AOP Alliance jar. So, because I hate all those dependencies too. Yes?
Do you need the AOP Alliance for other things than injectors?
So really, version 1 of the AOP Alliance really only specifies method interception anyway. So there's just like a couple interfaces in there. So, but that is the only interface Guice supports anyway.
Okay, so it's a tiny one.
Oh yeah, it's really small. Yeah, there's like maybe 1 or 2 interfaces in there.
When you're doing like a unit testing, you inject data.
So yeah, you can inject, when you're doing the unit testing, can you inject data? Yeah, you can do, you can do whatever you want. I mean, it's like I said, it's kind of a nice thing about having this programmatic API for configuring bindings. You can build whatever you want on top of this. Like you could have a utility method that reads in an XML file and makes so you can inject it, like inject the DOM, right?
large application, how bad does the module definition get? Like, how heavy does it get?
He asked on a big application how complicated your modules get. And it really depends. You only have to explicitly define bindings whenever you have an interface, whenever you're depending on an interface. So it depends how many interfaces and implementations you use, right? So, but compared to other frameworks, it's a lot less than you would typically have. So, yes?
From our experience,
Kevin knows better than I do.
The modules that we've been developing in Edwards don't really get more complicated. You just get more of them. So we're now, we have maybe 50 modules in our application now. And when one starts to get too big, then we usually chop it up. And that makes it usually like the unit of granularity for a module is like the set of things that you would typically want to test together as a unit in like sort of a functional test. So if you'd say like I want to test how these pages work, but I want to mock out the entire billing subsystem, and put the billing subsystem in one module and the UI for this section in another module.
That's great advice. Cool. Yes?
So you were saying you want all those advantages about using Guice. I wonder whether there's any case you will discourage that.
No. She asked if there's any cases where... She asked if there's any cases where you would discourage use of Guice, and well, it doesn't work on a mobile phone yet. Outside of that, I mean, it's just really so simple. It's not, it's not really that. There's not a lot of risk to it, So, and it's always good to write unit tests. So, and Guice helps you do that. So.
Do you guys have any measurements on the performance hit of using injection versus not?
He asked, how's the performance? We care very much about performance. And it's the difference between doing this stuff by hand and using Guice to do it is literally, it's negligible. Like you really couldn't tell. I mean, it's so close, you're talking like nanoseconds apart. So you can create millions of objects in a loop with Guice and it'll still be fast. Cool. Oh.
So are there any listeners that you can apply to the scope? So if you have a custom scope, so that you can have a listener when that scope goes out and do some sort of cleanup on the objects you constructed?
He asked if there's any listeners for whenever the scope gets teared down. And we do get that request a lot, but we don't support it yet. So I'm not quite sure exactly how that's going to work as part of the reason. So actually, we could use like more use cases for that, so where you could like say exactly what you want.
So did you purposely call your providers rather than factories?
He asked about the fact that we named the provider interface provider. That is kind of a strange name, right? We named it. That's Kevin. No, that's good. It was good. It was a good rename. Kevin is great at coming up with names for the APIs, and the Guice API looks very much like it does because of Kevin's influence. And provider is one of those things. And I think it makes sense. I think there's kind of this connotation with factories that it creates a new object every time, whereas that's not necessarily the case with providers, right? It's like it could be returning the same object every time in the case of a singleton or whatever. So we wanted to be a little more generic.
So there's, so as you split something up into a bunch of modules, in the Guice context, is there any relationship between modules? I mean, are you binding modules to each other, or how does that work?
So he asked if there's any relationship between modules, and hopefully no. Kevin, do you ever have any situations where?
So you can structure modules in a tree structure.
Oh yeah,
it's just a convenient way. If you have 100 of them, and 50 of them tend to go together, you can make another module that includes all those. And actually, in Guice 1.1, we fixed it so it doesn't even have to be a tree. If the same module wants to get included twice, it will just realize that it's already been installed and move on. But I would encourage you to think of this structure like your JUnit test cases and your test suites, where you either have something that contains other things or you have something that's a leaf. Because if you go too far with like having modules that both define bindings to implementations and include other modules, then you're creating compile time dependencies between modules, which is exactly what Juice is trying to help you not do.
But maybe I didn't get the stable question quite right. Basically, it's all these modules are part of the system. So I'm just trying to understand if Juice is saying anything about how those all get put together, or if that's outside of Juice.
When you say put together, can you be a little more specific, maybe? Maybe like with an example?
So between two modules, typically there's some interface.
Right. So this module has...
Module's going to interface with every other module. But, so is Juice doing binding between modules?
Yes. So you're saying, like, you're asking, so we have module A and module B. Module A has classes that depend on interfaces bound by module B, and module B might have classes which depend on interfaces defined by module A. And yeah, Juice is the thing that brings these modules together and makes all that possible without module A and module B having to depend on each other. So the idea is you could take module A and reuse it with an alternate, like a fake implementation of module B if you wanted. One other thing I wanted to talk about there, well, first, Kevin needs to give a talk on design patterns related to Juice. But second, so module is a really generic interface. And one of the things that I had in mind whenever I defined it was being able to kind of write these utility methods that you can use in your configuration too. So you can write utility methods that return providers, and that just can create those. But you can also write utility methods that are implemented as modules, and then call those from your other modules. So like you could provide, like for the web service thing, like say you had to create a couple bindings to make that happen. Well, you could give a factory method where I give you the interface and the URL, and then you give me back a module that creates those three bindings without me having to know about it. Cool.
Oh, hey, this is on. Very cool. I just wanted to make sure that we plug how to find the project page and get on the mailing list, because I always forget to do that when I've done these talks, and Bob was forgetting to do it too.
I did forget, and I told myself I wouldn't.
So all you have to do is type in Juice, G-U-I-C-E, to your favorite search engine on the internet, whatever that may be. And on the one that I use, our project page comes up first. It's hosted on code.google.com. And right from that page, there's a link to the downloads, to the Java docs, and two mailing lists. There's the regular mailing list and the developers mailing list. The developers mailing list is very chatty. You'll get email every time we update the wiki. It's really silly. But the main user list has a couple hundred subscribers, and we have lots of good traffic, users helping users. So I recommend getting on there and giving us your feature requests and stuff.
And if you speak Chinese, we have a Chinese translation of the user guide too.
And Portuguese.
And Portuguese?
Maybe not of the user's guide.
Okay.
It's like somebody wrote a tutorial in Portuguese.
Cool.
And we linked it.
Cool.
Yeah.
Didn't even realize. All right. All right. Thank you very much for everybody for having me.
Thank you.